Hey guys, today there is a nice trigonometric problem. This is actually an inequality that we have to prove that if A, B, C are real positive real numbers and there's some pi, so prove that 1 over sine A over 2 plus 1 over sine B over 2 and plus 1 over sine C over 2 equal or greater than 6. It's actually a nice problem, but when we try to prove, for example, an equality includes a trigonometric function. So there are, if we approach it, the one of the ways, of course, when we do it, actually, we think about including geometry here, but sometimes it doesn't work. So actually, we have to know the basic trigonometric inequalities to just, use them for the solution of different problems. So, for example, in this problem, it might seem to persuade us to use geometry, but actually there is no need to use geometry. Okay, so we have actually kind of inequality. First, when we begin to prove an inequality, we don't take special attention to what actually is. For example, what is greater than what? Then it's greater or it's. Now we just look at the given expression. So okay, let's look at solution. Let's prove. Okay, so we know that if we look at this, just if there's some pi and they're positive, of course, then sine also positive, sine and sine function positive. So okay, because sine is odd function, so for sine we know that sine minus x equal minus sine x. But here there is no need to remember this fact to see because all the values positive. Okay, fine. Anyway, let me just erase this. This is just remembrance. Fine. Okay, now let's first apply here Cauchy inequality and see what happens. So if we first apply here Cauchy inequality, we will get kind of weird and also ugly expression. Feel like 1 over sine A over 2 times sine B over 2 times sine C over 2. From the first impression, it looks like the expression, for the solution we got here, just looks ugly and more troubling than what we had. Actually, that's not like that. But just let's imagine we already completed the first step. The second step to do something regarding the product here. So now at the second step of the inequality, for the proof of the inequality, we have to work on the product of sine A over 2 sine times sine B over 2 sine C over 2. Okay, let's look at this expression. So C is C is just pi minus A plus B. We also know that fact. That's fine. So let's for just for better step, let's say. Let's convert this product to some of the trigonometric functions. When we do sine, for example, m times sine, as is nothing but half the cosine. It will be a minus b over 2, so minus cosine a plus b over 2, so times sine c over 2. Okay, that's fine. So first we got this, that's fine. So if we look at this part, we see that we did something, we just changed this part to cosine function. So what can the expression with cosine give us? Actually, it can develop because that this expression, if we want to prove something, we have to kind of find the borders of the expression. So we have to kind of estimate the expression. So look at this one. We see that actually, if for example A approaches B, So in this case, cosine a minus b over 2 will somehow approaches 0. So cosine 0 is 1. So we know also that the 1 is the principal value of cosine function, at which function becomes maximum. I mean, just the greatest, or you guess it's the greatest value. Anyway, so we can write like this. So this expression, so let me first erase this part because we already used here. So we can actually erase here. So let me erase this part. So actually we knew that this expression, let me write it again here. So half, so cosine a minus b over 2 minus cosine a plus b over 2 times sine over 2. So can be like this, can be equal or less, yeah. So let me erase this part already. So it will be, okay, so it will be half because it's a maximum value of cosine a minus b is just 1. It will be like 1 minus cosine a plus b over 2 times sine c over 2. But we still have sine c over 2, which is also problematic because we know that sine can be, and c here, can be replaced with other expressions, other parameters actually, a and b. So let's do it. So here it is half 1 minus cosine a plus b over 2 times, the sine is, so we can write it sine, so c over 2, c actually, if you look at this, c is nothing but pi minus a plus b. So if we divide every, this side by 2, it will give us pi over 2 minus a plus b over 2. So let's write now here. So instead of sine c over 2, let's write sine pi over 2 minus a plus b over 2. So that's fine. So actually, we know that it's half. So 1 minus cosine, so a plus b over 2. So we know that this expression cosine is sine pi over 2 minus like alpha. It is cosine, so we can write it times cosine, so a plus b over 2. So we already here got it's multiplication. We already got here just quadratic expression. So for this quadratic expression, we can actually apply mn or just which method to find its maximum value. Because let me first erase it to show you. So we don't need this anymore. Okay, you know that this expression will be like, it will be here. Let me continue. It will just, if we just write a cosine like m, it will be half 1 minus m times m. So it will actually give us m minus m squared over 2. So actually we can easily show that the maximum value of this expression is 1 over 8. So maximum value. But why maximum value? Because here a is minus, so the function will have maximum value. So that's fine. M is the maximum value. So this expression actually is the expression we in the beginning believed to exist. Sine a over 2 times sine b over 2 sine c over 2. So this whole expression, actually, this result actually is a result of, if you remember, it was like sine a over 2 times sine b over 2 times sine c over 2. So it was like 1 over 8 we proved. That's fine. But if again we come back to the result, so if you remember, just at the beginning of the video, I just wrote the very famous inequality, Cauchy inequality. So inequality is like, so it was like 1 over sine a over 2 plus 1 over sine, so b over 2 as you see. So then it's 1 over sine c over 2, so equal or greater 1 over, actually it's 3, here's 3 times, so like, so it was sine A over 2, sine B over 2, and sine C over 2. That's fine. So this expression is equal or less than 1 over 8. In this case, their product, like the sine M over 2, like product, will be equal or greater than 8. So this is a fact. So we can't deny this fact. So if we get third root, it will be third root here. So third root here, it will be 2. So it will be somehow 2. It will be 2, so it will be 3 times 2, which is 6. So that's the result we wanted to prove. So I hope you understood everything. It was really understandable because in Olympiad problems, one of the just skills we have to increase, of course, is to be able to find the relation between geometry and algebra. But although we didn't apply any geometric knowledge here, we sometimes need, of course. But here in this problem, knowing trigonometry, knowing inequalities, and using them for different problems actually always gives us an advantage. So this is an example I gave you to know how to for example, memorize this nice relation. And also, in the solution of this problem, we also saw that the product of the guys with half angle is equal or less than 1 over 8. So this is two nice facts. One fact is actually this, and the other fact is the result. So you can use these two facts for different problems. So that is the end of the proof. Okay, see you guys.